The EGR monitor. The EGR monitor uses manufacturer-specific methods to measure EGR operation, and hence flow, and to diagnose flow problems. We can discuss each one of them separately, and one of these types will apply to almost any manufacturer of vehicles there is. But we're going to start with Ford because Ford is a little unique. Ford's EGR monitor uses a delta pressure feedback, EGR sensor, DPFE for short, to measure EGR operation, flow, and diagnostics. Now, in this particular case, let's take a look at how it works. The DPFE measures a pressure drop across a metered orifice, which is a restriction in the flow pipe leading into the EGR. As we have EGR flow, low pressure will develop on the downstream side of the orifice. What happens then? The DPFE takes this difference in upstream and downstream pressure and calculates flow as represented by a voltage. Puts it out on a 3-wire sensor back to the PCM. What the PCM is going to do is it's going to take this flow calculation and determine if the flow is correct, high, low, or non-existent. If we have no flow with EGR opening, we set a code. If we have the correct flow, it's going to maintain the current duty cycle on the EGR vacuum regulator. Now, the EVR valve, as it's sometimes called, regulates the vacuum supply to the EGR, which in turn controls the size of the opening. When the PCM needs to have higher flows, it commands a higher duty cycle, which results in a higher manifold vacuum being applied to the EGR, and it opens the EGR more. To reduce EGR flow, it reduces duty cycle. The vacuum regulator cuts back on the amount of vacuum applied to the EGR, and it closes down. The PCM is going to continuously monitor the EGR flow rate and try to maintain the ideal EGR flow rate to control emissions and to eliminate pre-ignition or detonation, spark knock, whatever name you want to call it. Now, we have a picture here which is not worth 1,000 words because you can't see that little ring we have redrawn there, showing us the orifice. And here it is on an actual vehicle. We have our two pipes, and the orifice in between those two pipes. The hot gases come back through here and go to the EGR. So the PCM is going to utilize this sensor here in the square to control the EVR, which in turn is going to give us the correct flow. And when the flow is correct or incorrect, it's going to be utilizing it for testing. Now, the problem we have is there is not a standard DPFE sensor. It is a non-zero return, meaning zero flow does not equal 0 volts. We have two voltages. We have an old-style metal sensor, and we have a new-style plastic sensor. Now, zero flow on the old style was 0.45 to 0.6 volts, and a few of the late generation old styles had the new flow of 0.9 to 1.1. Now, the PCM is going to learn this value at key on engine off, and it's going to establish 0. So we can replace the old style with a new one, and the vehicle will adapt to it. And we're going to show you by the numbers where that works. One of the things we advise is that the older metal style sensors should be replaced because they tend to short out and cause really bad problems in some cases. Pull B+ down and shut the computer down in a few rare cases. The most common failure is to screw up ground and not show proper flow, causing a false EGR flow code. Almost every plastic sensor, almost everything we've seen lately, metal one, has been replaced by plastic. We see very few metal ones. We see a metal one, we know it's somebody that doesn't know much about Ford. But Ford has a new system called the EGR System Module. Unlike the old DPFE, this new DPFE has 4 wires. And we have moved the orifice. The orifice is now at the intake to the manifold. And the upstream reference has been moved from out in the tube to inside the EGR. Now, what this does differently is it gives us manifold vacuum as a reference. The other hose on the EGR, on the DPFE, goes to the EVR and then on over to manifold vacuum. From here we can read map voltage, we can read barrel, and that brings us to a new problem. Since we now have a barrel sensor built into the DPFE, some of the diagnostics many of us have been using to diagnose dirty mass airflows and vacuum leaks is to look for the barrel frequency being way too low. Well, that doesn't work anymore because now barrel is going to come from an actual sensor built into the DPFE. Function-wise, it does the same thing. It looks for pressure drop across the orifice. If it knows the pressure on the exhaust side and the manifold side, it can compute flow, assuming we have no restrictions in the system. We're going to talk about how we're going to look at those restrictions, but just be aware the new ESM will also have codes 106 and everything associated with MAP. Now, when they start talking about MAP, we are in fact talking about the DPFE sensor on today's newer cars. So we're going to start talking about the parameter IDs in scan data. We've got to do some very important testing, and the sensor must indicate 0. I know the slide says should. I'm going to take it strong and say it must, and it must show a change in voltage for EGR flow. These two things must happen because we're going to be utilizing this DPFE sensor for more detailed testing. So I want to pass two tests. One, I want to indicate 0 flow, key on engine off. It must change when I open the EGR with a vacuum source or whatever and cause EGR flow. If it does these two things, I can utilize it to do some additional testing. If it fails one of these, I want to change the DPFE sensor right here, right now. This is the source of a great many false problems, and it's a good place to stop and say it's time to make some repairs right here before we go any further. The point we're trying to make about replacing a defective DPFE sensor is that it will keep out our other diagnostics from working. So we always test the DPFE sensor first because its trouble code threshold is typically very wide, about 0.2 to 4.9 volts. And if the failure doesn't fall in this bad range, it won't set a code. A failed DPFE can be identified by the voltage not within specifications and the fact that it does not move when the EGR is opened. Now, we've already told you to verify operation, and we assume from this point on you have a good operational DPFE sensor. Once we have that, we're going to start looking at EGR flow versus the voltage. Now that we know that it's working, we want to see that it works reasonably well. Now, let's pick a number. 4 inches of water is a typical number. It's right in the middle here. That's what we sometimes see driving down the highway. Now, the EGR is going to be controlled by the DPFE sensor's duty cycle. And it's going to vary duty cycle. And it's going to vary it until the voltage matches the magic number. Now, let's talk about these two systems. There's about a 0.5 volt difference between these two systems. So if we have 4 inches of mercury in the top one, we're going to have about 225 to 250. Let's say 250. That's the old style. The new style should have a right around 3 volts. It does. The learned offset will take care of differences. So we're going to expect to see around 295 in the new style sensor and around 255 in the old style sensor, just to use one of the numbers in the range. About a 0.5 volt difference, and that's about the size of the difference in these two systems, from 0.45 to 0.6 versus 0.9 to 1.1. So we can see that the auto ranging system works. First thing we wanted to prove to you, auto ranging works, so you can put a new one and place the old one with all the confidence in the world. Now the PCM is going to vary EVR, EGR vacuum regulator duty cycle, until it achieves this magic number, whether it's 255 or 295, depending on the sensor you have. Now what we find when we go look at the EGR duty cycle, which we're adding into this picture, is we've got it banded into a red, green, yellow, orange, whatever you want to call it. What we find, and this is true of all EGRs, normally EGR duty cycle, whether it's directly or through a vacuum regulator, run between 30 and 70%, with most of the time spent between 40 and 60. When flow is normal, we're cruising down the highway, light load cruise. Now that means we're going to be using, if we stick the green range and go to the right and look at the vacuum, we're going to have from 2 to 3.75 inches of vacuum applied to the sensor. If you're up around 5 or 6 inches, as you can see on the right, we have excessive vacuum needed in order to achieve our magic number. Remember, these numbers here relate back to the DPFE numbers. That's why we told you so specifically to get the DPFE working and have a good DPFE before we start this test. So we started this test and we're saying, okay, when everything is normal, well, let's talk about some differences here. Let's say to get 4 inches, it takes 90% duty cycle. We're going to have to apply right at a 6-inch vacuum instead of a 3 3/4 inch vacuum. We've opened the EGR significantly more to achieve the same flow through the EGR as measured by the DPFE sensor. You have to question why that's true. The other side, what if we only open at 10%? We need 1 inch of vacuum to get the flow we need. What is this trying to tell us? Let's stop and examine this circuit a minute. The EVR regulates vacuum to the EGR to achieve the desired flow. That desired flow is measured by the DPFE sensor. So what does differences in duty cycle tell us? Well, higher than normal EGR duty cycle. But the vacuum doesn't match the expected value. In other words, we got a 90% EVR, but manifold vacuum is 2.8 inches. Oh, we got a leaking hose, we got a plugged vacuum hose, we got a plugged EVR solenoid. The reason we added the vacuum values in is that tells you the relationship of EVR versus manifold vacuum, or vacuum applied to the, not manifold vacuum, but vacuum applied to the EGR. Now, we do have a situation with plugged tubes. We've taken a yellow sheet of paper here because it's very hard to see this plug. It is solidly plugged. Here's what we found. We're well above normal. We're up around 95 to 100% EVR. But we did not show normal flow. So what's happened? Trying to get flow, the PCM increased the EVR. It never saw flow, and it took us to this particular case. Now, in this case, a code found it for us, made it very easy. So if we have lower than normal EVR, what would that be? Totally the opposite problem. It's low, but we only take 1 inch of vacuum to get all the EGR flow we need. We have excessive back pressure, or we have excessive EGR flow. Either one will give us this problem. Now, this type of diagnostic will work for any vehicle. You may not have a DPFE. You may not have a vacuum regulator. It may be a duty cycle. It may be a position sensor, but it's going to tell you the same thing. If flow is high at idle, it indicates the valve is leaking or stuck open. And that's exactly the case with this valve. You can see it stuck open. So here's what we've done. We've taken mode 6 information. We're going to look at it. We've taken scan data to this point. We understood how it all works. And we've made sure you understand that all of this depends on the DPFE sensor working normal. And we also found we have false codes on forward, and we're going to talk more about that. So let's get this put to bed. We all understand how the monitor runs, and we all understand why we can get false codes if we have a non-functioning DPFE sensor. Now, before we leave forward, let's make sure we have put this DPFE sensor to bed. We really have 3 generations now. A new one with a map sensor built in, 4 wires. These are the 2 older 3 wires. The old metal type on the left has a higher failure rate and should be replaced by the new plastic. And what we're saying is, before you do anything, make sure that DPFE can read 0.9 to 1.1 if you got the new one. Could be on the old one, you're reading 0.45 to 0.6. Key on engine off if it cannot read that voltage. Go up to the schematic, do the green test for voltage on the red wire and make sure you got 5 volts going to pin 2. Then make sure you got a good ground under 50 millivolts going to pin 6. If power is good, ground is good, and the voltage you measure on pin 5 for the DPFE signal does not match engine off, change the DPFE sensor. Next part of the test, you open the EGR valve to where you hear change in EGR or engine RPM. If there is no change, you probably have a plugged up system. If there is a change, make sure the DPFE measures that change. We want to do this to make sure DPFE is functioning and all the diagnostics we gave you are working properly. Now let's move on and talk about other EGRs. Chrysler poses some special problems for them. They use short-term fuel trim to monitor changes in EGR position. Now, short-term will vary slightly, increase in reality with normal EGR flow. Slight increase means we have slightly lower manifold vacuum. And for it to work, we've got to be over 180 degrees Fahrenheit engine temperature. The problem we have is finding scan data on EGR position or EGR duty cycle. What we've had to do is graph EGR duty cycle versus map voltage with a lab scope. Now, we could go out and get a DRB3 in dry grafting, but we understand that not every shop has access to a DRB3. So we have chosen to use the EGR position sensor test for GM. Here's the basic rules. Excessive changes indicates excessive EGR. No change indicates no flow. Doesn't matter what we're going to use, whether it's short-term or map sensor, because GM uses the map sensor to monitor changes caused by the EGR. The map sensor will also change on a Chrysler. Although we're looking at a slightly different thing than Chrysler looks at, we can still utilize it. Map voltage will increase slightly with normal EGR flow. Excessive changes indicates excessive EGR. No change indicates a blocked or plugged EGR. Here are our voltages. We've got the EGR duty cycle at the bottom. It's going from 0%, where the red is pointing right now, up to about 37% in a little stair-step arrangement. If we look at the mass airflow just above it, it's making similar stair steps. And if we look at the map sensor voltage above it, it does exactly what we expect. Now, the way we do analysis is we look at the time of a step change. We have the dotted line now showing that we have gone from 0% up to 19% EGR. That's what the data tells us. It's open the EGR up, we see mass airflow change, and we see map voltage go up. This will work for any vehicle you're going to look at. It monitors changes in airflow when the EGR duty cycle is cycled on and off. Now, that changes in airflow will show up in mass airflow various ways. It always shows up clearly in map sensor voltage. You can see each step of the EGR duty cycle is followed by an appropriate step in map sensor. And map sensor voltage has not dropped off the map. That's the important thing. It did not make large changes. So the Chrysler monitor, your scan tool has to play duty cycle, and you use it on the DSO. We would do the same thing. Just not available when we utilize it without a DRB. Hopefully, somebody will catch up and get us information on Chrysler EGR. But you can use this on Chrysler. You can use this procedure with a map sensor on Toyota, Honda, Nissan, anything else. This completes the EGR monitor. You should understand some very detailed operation about the EGR and how to do the proper EGR diagnostics. Remember, you need to have quick, fast diagnostics. We've shown you how to identify the false codes that show up in forward without spending too much time. Hopefully, this is going to solve any EGR problems you may have.